notice we don't see any number here in the index, also known as the root, so this is a square root automatically. Whatever number you have inside gives you a horizontal shift. Whatever number you have outside that's not underneath the radical with the x, this is a vertical shift when it's being added or subtracted. That's enough to know what the starting point is, but if you want, you can do some other things. You can identify the domain, specifically so you know which numbers you can pick for x. Now, ordinarily, a square root function goes off to the right like that. But what we're going to do is get the exact numbers. To find the domain, you take the part underneath the radical and you say it has to be greater than or equal to 0. And so you subtract 3 from both sides. This means that x has to be greater than or equal to -3. And we can flip this around. And if you want, you can make a number line. You'd have the -3 on the far left. Because this can be equal to -3, you draw it with a closed circle or a bracket. And you can pick numbers on the right of that. So that's the idea. You can't pick, for example, -4. It's not in the domain. But you can pick things like 0, 10, and so forth. You won't necessarily want to pick 10, you just want to pick numbers that make it easier to graph this. Now, one more thing you can do. We know that it starts at -3 and goes to the right, but also because of this -5 that's out here by itself, that means it got shifted down by -5. And you can either sketch this using that property, or at this point you can just switch to finding actual points to plot. We'll say that y is the same thing as h of x, and then we have the square root of x plus 3, and then a -5. Here, the farthest left number we can pick is -3. So what you can do is find out what this is. You go ahead and plug this in. Underneath the radical, that's 0. The square root of 0 is 0. So this ends up being -5. This is the starting point. This is -3, -5. And then we'll just pick some other points. Ideally, we would be able to pick numbers that will give us integers as a result. But you can just pick any random number as long as it's to the right. Meaning, you can pick 0 next. This is normally a good one, but not always. Now, here I'll tell you this. Because you have to find a square root, what you want to do is try to get a perfect square underneath the radical. So you pick some number for x that when you add 3 to it, you'll get a perfect square. And then when you find the square root of that, you'll subtract 5 and you'll still have an integer. So what you want to think about are, what are some perfect squares? And we'll just go in order. When you square 1, you got 1. When you square 2, you got 4. When you square 3, you got 9. This will be enough. You can go up to as far as you want on paper. So these are some perfect squares, and we can pick any of these, or you can go further and pick something from 25 and beyond if you want. But let's try to get a 1 underneath the radical. And you might see how to do it right away. Or if not, what you can always do is take the part under the radical and set it equal to the number you're trying to get. Then you subtract the 3 from both sides, and this tells you that the next number we should pick is -2. And when you do that, and you put the -2 underneath the radical where the x is. This turns into a 1. And so the square root of 1 is 1. And you got -4. So the next ordered pair where we have integers is -2, -4. And then after that, you can take the part underneath the radical again. Take the x plus 3, set it equal to 4. When you subtract 3 from both sides, you got x equals 1. So that means that the next number you'd want to pick if you're trying to just stick with integers would be a 1. And you put the 1 underneath the radical where the x is. This means that we have the square root of 4, which turns into a 2. When you subtract 5 from that, you got -3. So this is one way you can just make sure that you work only with integers. Now you take the x plus 3, set it equal to the 9, and you subtract 3 from both sides. This means the next number we should pick is 6 if we want to still work with integers. So you take the 6 and you substitute it for the x. This turns into a 9. The 9 is a perfect square, and the square root of 9 is 3. So then the next one would be 6 -2 if we're only using integers. And we'll do one more. We'll set the x plus 3 equal to 16. Then you subtract 3 from both sides, and you find that x equals 13. So you put the 13 here, where the x is. And it turns into a 16. The square root of 16 is 4, and so you end up with a -1. And so this ordered pair is 13, -1. Once you have this much information, that's everything we need to start graphing. We'll set up a rectangular coordinate plane. Go ahead and plot these points. Let's say this is where -3 is. And this is -5. This is the first point. Then we'll put -2, -4. That would be right over here. Then we have 1 and -3. The point would be right about here. Then we have 6 and -2. That would be right about here. (13, -1), that would be right about here. And then you go ahead and graph this. It'll go beyond the 13, -1, so you can even put an arrowhead if you want. And that's basically how you graph this one. You're just finding points to plot. So this is one way you can do it. For this, do you have any questions about anything?
No questions.